We dream of interstellar travel and the conquest of space, but for this reason, we will never be able to leave the solar system. It is shocking that we seem to be stuck on this planet, and with the prospect that this world will no longer be habitable in 100,000 years. Where is the solution? Do we stand a chance of surviving in the long term and colonizing space? Scientists paint a grim picture. In a few hundred years, Earth could become a hot greenhouse, with rising oceans swallowing large swaths of land. Imagine an Earth where iconic metropolitan areas like New York, Rio de Janeiro, and Hong Kong simply vanish. Millions flee inland, diseases devastate populations, and the animal kingdom struggles to adapt, with many species disappearing. Oceans teeming with life become barren, and Hawaii exists only in folklore. Cities now cling to mountain peaks once revered as Earth's highest. This grim fate looms if we heed scientific warnings. Entrepreneur Elon Musk, a pioneer in space exploration, advocates for space colonization as our survival strategy. Is Musk's vision the answer, or does NASA hold a different path? Elon Musk's ambitious plans include transforming Mars into an Earth-like habitat through terraforming, a process involving the strategic use of nuclear warheads to unlock water deposits at Mars's poles. NASA initially dismissed the feasibility of terraforming Mars, but little known is that NASA itself had similar plans in the late 1980s. However, technical challenges, financial constraints, and setbacks like the Space Shuttle disasters halted progress. Subsequently, NASA shelved lunar and Mars colonization plans until Elon Musk reignited interest in space exploration. Presently, Musk and NASA collaborate on the Artemis project, aiming to establish a manned lunar station within a few years. While NASA focuses on the scientific aspects, Musk contributes expertise in technology and potentially tourism. The lunar station also serves as a stepping stone for Mars missions, indicating that human settlement on Mars may not be far off. However, Mars is not a long-term solution, as it will eventually become too small or inhospitable for human life. This realization prompts the consideration of leaving the solar system, as few other worlds within offer habitable conditions. Despite this, it's established in scientific understanding that crossing the solar system's boundaries is impossible. The vast distances in our solar system highlight the challenges. Earth to the Sun spans 150 million kilometers, with the Earth-Moon distance at 384,000 kilometers, and to Mars around 225 million kilometers on average, varying with orbital positions. Further distances compound the issue, with Jupiter lying 778 million kilometers away, Pluto at 5.9 billion kilometers, and the edge of the heliosphere at 100 AU, equivalent to 14.96 billion kilometers. Examining our technological capabilities adds to the complexity. The Parker Solar Probe, humanity's fastest spacecraft, travels at 700,000 kilometers per hour, while Elon Musk's spaceships achieve speeds of 27,000 kilometers per hour. The journey to Mars for the first settlers will span approximately 6 months aboard the spacious and comfortable starships, showcasing advanced technology. However, contemplating travel to the outer reaches of the heliosphere reveals significant challenges. If a starship were to undertake such a voyage, it would require well over 100 years to reach its destination. Even with current technological capabilities, a journey to the next solar system would take several thousand years. These realities prompt reflection on the future of interstellar human exploration. Is the dream fading, or are we neglecting the possibility of faster-than-light travel? Conventional spaceship travel likely confines us within the solar system due to the immense time required to traverse distances. Achieving our aspirations as a spacefaring civilization hinges on the development of innovative technologies. The concept of a warp drive, once confined to the realms of science fiction, gained credibility in the 1990s when scientists like Mexican physicist Miguel Alcubierre demonstrated its mathematical feasibility. However, practical implementation remained elusive. Nonetheless, ongoing scientific inquiry has brought us closer to realizing this propulsion system, with various concepts emerging. Despite progress, the primary hurdle lies in fuel. Physicists and engineers are optimistic that advancements in the coming years or decades will enable the manipulation of space-time, defying previously immutable physical laws. These breakthroughs hold the potential to revolutionize space exploration and travel. The field of astrophysics is currently experiencing a significant upheaval, often referred to as the crisis of the century. Recent observations made by the James Webb Space Telescope challenge our existing physical theories, suggesting the need for a re-evaluation of cosmological principles. These shifts in cosmology could potentially pave the way for new breakthroughs in physics, offering novel perspectives and avenues for exploration. In light of these developments, it is conceivable that we may soon unlock technologies enabling space travel through manipulation of space-time, transcending conventional methods of traversing vast distances. While the notion of space-time travel, particularly through extraterrestrial technologies, may seem far-fetched, the prevalence of UFO sightings around the globe underscores a growing fascination with the possibility. Reports from credible sources such as fighter pilots, airplane pilots, and ship crews describe sightings of disc-shaped objects, flying eggs, and triangular craft that defy known laws of physics. These encounters, often involving multiple witnesses, contribute to the ongoing discourse surrounding the existence of extraterrestrial life and advanced spacecraft. The frequency and credibility of UFO sightings have reached such heights that a hearing was convened before the U.S. Congress. In 2020, David Grush, a former UFO special representative of the U.S. Army, testified before Congress, alleging that his superiors had deceived him for years. He claimed that the military possessed multiple crashed UFOs but had kept this information concealed. This testimony echoes the assertions made by renowned UFO leaker Bob Lazar in the late 1980s, who asserted that he had conducted research on UFOs and an unknown element in a clandestine facility. This element purportedly enables the manipulation of gravity, facilitating faster-than-light travel or space-time manipulation. Lazar's claims garnered both adoration from UFO enthusiasts and skepticism from authorities. Lazar additionally detailed 9 distinct types of spacecraft allegedly owned by the military, suggesting efforts to appropriate such technology for themselves. This pursuit likely commenced following the Roswell UFO incident in the late 1940s. Despite these efforts, attempts to reverse engineer the technology have faltered due to challenges in producing the elusive element 115 necessary for propulsion. In 2003, scientists achieved a breakthrough by artificially synthesizing element 115 in a laboratory setting. However, the synthesized element proved unstable for use in a reactor. Nonetheless, this development confirmed the existence of element 115 in a stable form, potentially existing elsewhere in the universe. Its properties could potentially enable the propulsion systems described by Lazar. These narratives reveal an intriguing progression. In the late 1980s, scientists dismissed Lazar as untruthful and element 115 as a mere fabrication. Nearly 20 years later, however, the element was indeed discovered, albeit not yet in the stable form purportedly utilized by extraterrestrials. If extraterrestrial beings truly exist, it follows that their technologies exist as well. It may only be a matter of time before we replicate their inventions. If you find this concept far-fetched and incompatible with established science, consider the vision of Russian astronomer Nikolai Kardashev. Kardashev, a prominent figure in the field of astronomy, devised a scale delineating the development of civilizations based on their capacity to harness and utilize energy. This scale posits that factors such as quality of life, intelligence, and societal advancement correlate with energy utilization. According to Kardashev, there are 3 types of intelligent species. Type 1. Civilizations are in the nascent stages of development, relying on unsustainable and detrimental energy sources like coal and nuclear power. Type 2 civilizations have overcome this challenge, achieving harmony with their home planet. Type 3 civilizations possess the ability to extract energy directly from stars, signifying an advanced level of technological prowess. Beyond this scale lie civilizations capable of manipulating matter, transcending the laws of the universe, and becoming co-creators of existence. These highly evolved beings could harness every conceivable energy source, traverse dimensions within the multiverse, and undergo spiritual transformation. Currently, humanity finds itself at the outset of Stage 1 on this scale, with the potential to progress to Stage 2, contingent upon addressing issues such as sustainability and global harmony. Therefore, concepts like faster-than-light travel, extraterrestrial life, the multiverse, and interdimensional travel may not be as implausible as they initially appear. Their feasibility depends on one's perspective. If humanity eventually embarks on space-time travel, it would entail not venturing beyond the solar system in the traditional sense, but utilizing the unique properties of alternate dimensions for space exploration.